Welcome to HL Congruence. Stands for hypotenuse and L stands for leg. So let's say we had these two triangles and we wanted to prove them congruent. So let me show you what they're asking for. So based on what they want you to prove, they want you to prove that triangle ABC, so that triangle right there, is congruent to BAD. So that one over here. And that's what we're going to do for this problem. Right, so I have two givens, and I'm going to take it step by step. I am going to use the first given. So in red, I'm going to say this part, angle CAB and angle DBA are right angles. So CAB is this one, and DBA, which is that one. Just trace over the letters and you'll see why I put the right angle in that precise spot. So that was done in red, just so you know. Statement 1 was given, and I did everything in red. Next, based on step 1, we can now do step 2. So based on step 1, once I say right angles, that means you can graduate to saying that the triangle that contains those right angles are right triangles. So I will say it again. Once you have right angles, you can graduate and say that the triangles are right triangles. So my second step led into my first step led to my second step. Sorry about that. And the answer for that and the reason for it would be definition of a right triangle. So just to show you what I did in step 2, I now formed that this triangle right here that I'm tracing over is a right triangle. And the second one that I'm about to trace over is also a right triangle. Okay, now let's go to our next step. Our next step I will be doing in green. It says AD is congruent to BC because of given. Just to verify, you can see that it is here and it is one of your givens. So I am going to just trace it over. AD is the same size as BC. So I want to tell you that the whole thing is congruent. Don't get confused and think it's only from here to here. I'm talking about the whole line segment AD and also BC. All right. Next, I'm about to do reflexive property. I'm going to do reflexive property with blue. So I'm going to say that AB is congruent to AB. So AB is congruent to AB. Notice I traced it twice. So at this point, you might be a little confused, but what I'm going to do is I'm going to separate my two triangles. So here we go. My first triangle looks like this. This is A, this is B, and this is C. I'm also going to use the same colors that I did for this whole proof. We already said that angle CAB is a right angle. And in case you can't see that, I will do it with a white background. There you go. Hopefully that helps. And we also said, according to this, in green, that AD right here is the same size as BC, so the green right here. And I'm going to just do it for BC because AD doesn't exist here. So I remember I traced this over and I put one tick mark. Finally, the very last one we did right here is AB is congruent to AB because of reflexive. So I traced this one over and I put two tick marks because it is talking about a different line segment, and that is one of my triangles. If I were to separate the other triangle, it looks like this. I'm not drawn to scale. A, B, and then D. First, in red, remember DBA is a right triangle. Right angle. So DBA, this one right here. Which if it's a right angle, it makes it a right triangle. What else did we learn? In green, we learned step 3 here, that AD was congruent to BC. So I have an AD here. So I'm going to make sure that it corresponds in color and tick marks to my first one, to BC. And then finally in blue, the last one we did was that AB is congruent to AB. That just means that if I separate the triangles, AB is still the same size in both triangles. And there you go. I separated the triangles. Hopefully it's a little easier to see. Then from here, you have to decide, do you have enough information to prove these two triangles congruent? The answer should be yes, and I will show you why. This is a right angle, which means this is a right triangle, which means across the right angle, if you want to make that into a little arrow and then point it this way, you'll see this is your hypotenuse. Same thing here. You can use that to make a little arrow. I used a little right angle to make an arrow, or if not, you could just do it right outside of it. So it's the right angle is always pointing to your hypotenuse. Then I can safely say that AB is just a random leg, because this would also be a leg. But line AB, the leg right there, happens to also match actually directly to the leg in this one because it was reflexive property. So you see that using HL, you can prove that these two triangles are congruent because I determined that it was a right triangle. So once you determine it's a right triangle, HL is a possibility. You don't always have to use SSS, SAS, ASA, AAS. Let's try another one. So it says that angle FGH. So that's what I'm going to do right here. In red are right angles. So this I'm doing red. And the only reason I'm doing it without showing you the proof is because I actually did highlight it here in red already. So FGH. And then also JHK. Don't forget that little box means right. I'm actually going to make it a little point here. There you go. Then from here, I'm going to start. So I did use my first given, the one I just highlighted in red, and I put the word given there. So we're good so far. Don't even need to trace it over. And from here, I hope you learned from the previous example. Once you say right angles, you can graduate to say that the triangle that contains the right angles are right triangles. So now I can say that this triangle FGH is a right triangle, and also JHK is also a right triangle. Right, next, I'm going to use another given, and I'm going to do this one in green. So notice here we have actually plenty of givens, so I'm using this one down here. FH is congruent to JK. FH is congruent to JK. Given to me, and it was already on the diagram. Okay, finally for our last given, I'm going to do this in orange. So it says H is the midpoint of JK. So H is the midpoint of this whole line segment. I'm only going to trace it over because I want to show you my next step. Once you have a midpoint, that means the midpoint of a line segment creates two equal parts because it is directly in the middle. And the reason for that is definition of midpoint. Once you have something in the middle here, that means you can say with certainty that GH is the same size as HK. I'm actually going to make that a little better right there. There you go. Because you know H is in the middle, you can say that these two line segments are congruent to each other. That will always happen. Once you have midpoint, that means two equal line segments were born out of it. Okay? Then from here, you should say, okay, maybe I have enough to prove these triangles congruent. And you do. So you have enough information to prove that this yellow triangle is congruent to this yellow triangle. And the reason for that is HL. So let's see why this makes sense. I'm actually going to draw this a little bigger over here. So you can see here, I'm going to draw, they both have a right angle. They both have the horizontal line segment as congruent to each other and the hypotenuse congruent to each other. How do I know this is the hypotenuse? Remember, you can take your little right angle and trace it to form an angle. The right angle always leads to the hypotenuse. And then this and this are considered legs, but I just need one leg to match the other leg. So do I have a hypotenuse matching a hypotenuse? I do. A leg matching a leg? Yes. And were they right angles in the first place, which means right triangles? Yes. So that's why these two triangles are congruent by hypotenuse leg. And now for the toughest question. Okay, so let's see. So we have that, actually we have a lot of information. I should have put the picture first. All right, so let me just give you all this information and then I'll go over one by one. Sorry about that. So I'm gonna put this here. Let's talk about this first information here. Oh, sorry, wrong color. I just wanted to say before I start, what I'm doing for this problem, because it doesn't have any directions, is that I'm going to prove that these two triangles are congruent by hypotenuse leg. So this is our goal, since I did omit the actual question. All right, so now that we know our goal, let's see how are you supposed to do this if you did not have all the answers. So first step, I'm going to make sure that this is correct information. So I'm going to put number 1 here. AC, the slope of AC, remember M means slope, is 1/2. If I go from C, which is the leftmost point, and I find the slope, is it 1/2? The answer is yes. Just a little refresher on slope. So let me make space here. I'm just going to put that this is our goal, but I'm going to put your slope is rise if it's positive, or fall if it's negative, run to the right. As long as you start from points from left to right. So just a refresher on slope. All right, next. I'm going to do your next one right here, which is the slope of AB. So if I start at A, 1, 2, 3, 4. That's a -4 since I went down. 1, 2. So my slope should be -4/2, which is -2, if you look right here. So my slope, I found it. And what I'm going to do here is now I'm going to say something about the slope. I'm going to say that, and look very carefully what I'm about to write. AC, the line segment AC, is perpendicular to AB. Okay, so you already learned perpendicular slope. A perpendicular slope is when you have opposite sign reciprocal, and the symbol is this upside down T that I was trying to make better, but I keep failing. There you go. So if one of your slopes is positive, the other one should be negative. And then the reciprocal of 1/2 is 2. So they are perpendicular slopes. So since AC is perpendicular to AB, so I'll trace that over actually, so you're not confused. AC had a slope of 1/2. AB had a slope of -2. Can I say that this is a right triangle because they're perpendicular slopes? The answer is yes, because once you have perpendicular slopes, that means a right angle was formed. All right, next we have, still in blue, the distance between AC. So all you have to do is write down your 2 points. Make sure you label it as x1, y1, x2, y2, and you do your distance formula. So here's your distance formula. Be very careful with your signs. So once I found this, the length, remember this is length, not slope, of AC, I'm going to put the answer right here, square root of 5. Then I wanted to find the length, the distance between point C and B. Again, don't forget this is x1, y1, x2, y2. And then you do your distance formula. Be careful with the signs. And you get 5. So this is from C to B, 5. And we're done with that side. Let's investigate the other side. So I'm going to say, is the slope of DF actually negative 1/2? So here's D, this is F. I'm going down, so that means negative 1, and then to the right, 2. So negative 1/2 is correct. Next, what I'm going to do is I'm going to check the slope of DE. So how can I go reach E if I'm at D? I have to go up 4 and to the right 2. And following my formula, that would be 4 divided by 2, which is 2. Then I think to myself, are those opposite sign reciprocals of each other? They are. So I can safely say that DF is perpendicular to DE, which means that I can do this. I'm going to trace it over again to show you which ones we found. To be perpendicular, which means I can put a right angle, because perpendicular lines create right angles. Then from here, we have to find the length of DF by using the distance formula. Remember, this is x1, y1, x2, y2, and you just follow the distance formula. At this point, I did realize that I did not include the distance formula, so I am going to include it here. Now that you learned your slope formula, here's a refresher on the distance formula. Your distance formula is your change in x's, which is the distance between the x's, squared, plus your change in y, again, that's just the distance between the y's, squared. And then everything is contained within a square root. So that's what I did for these 4 problems right here. So the distance of DF ends up being the square root of 5. And then I also did the same distance formula with EF, and I got just a 5 because it was the square root of 5. And then the last thing is left is to check whether or not you have enough information to prove these triangles congruent. First, do I have the square root of 5 matching the square root of 5? Yes. Do I have a right angle that points to a hypotenuse? That is 5. And a hypotenuse that points to, a right angle that points to hypotenuse, said that backwards, the number 5. Yes, I can put 2 tick marks here and 2 tick marks there. So since I have a leg that matches a leg, a hypotenuse that matches a hypotenuse, I can say that triangle ABC is congruent to DEF because of hypotenuse leg congruence. Goal was achieved. If there's any questions, please don't hesitate to tell me on Google Classroom or through email. This template was from SlidesGo.